Hey friends, I'm Scott Hanselman and it's another episode of Azure Friday. I'm here with Jayanta Mondal and we're talking about Gremlin for Cosmos DB and the Graph API, which is very exciting. What is Gremlin?
So Gremlin is an open source query language to query graph structured data. As you know, Cosmos DB supports a variety of different APIs, for example, MongoDB, Cassandra. Similar to that, we also have Gremlin. So now you can treat Cosmos DB as a graph database and shoot any kind of graph query at it.
So if I meet a person out there on the street who knows Gremlin, they may have used it on different databases.
Yeah.
They're going to feel very comfortable.
Yes. Yeah.
So they don't have to learn Cosmos.
No. So if you deploy Cosmos DB as a graph database, we will give you a WebSocket endpoint that understand the Gremlin query language. So not only Gremlin query language, if there are any tools that are out there that knows how to talk to a Gremlin endpoint, that can also work seamlessly. So any open source tool that's based on Gremlin can now talk to Cosmos DB.
So that's cool. So this person that I find who knows Gremlin, they might have a toolkit that they've built up of different things to talk to Gremlin.
Yeah.
That's cool.
Yep.
Is this hard to set up?
It's just a click of a button. So you just go to Azure portal and just say create a Cosmos DB account with Gremlin API. That's
cool. Do you have some slides or do you have a demo? What do you want to show?
I have some slides and also I'll interleave with some demos.
Let's do it.
So as you've already mentioned, today we are here to talk about Gremlin, the query language for Cosmos DB's Graph API.
Of course.
Today I'll basically cover about the anatomy of a Gremlin query, like how does a Gremlin query looks and why is it different from SQL or other traditional declarative query language. Okay. And then I'll talk about what are different categories of operations that Gremlin supports, so that if you're trying to write a graph exploration task, you know which type of steps or operation to pick from which categories. Okay. Right? So here is a quick example. So a Gremlin query looks like what we have listed down here. So it starts with G, which refers to your graph, and then you list down a set of operations that you want to perform on the graph. And the first key difference that I want to point out here is it's very procedural in nature, unlike declarative query language like SQL and its other derivative. So what it means is that when you're writing a Gremlin query, you are not only specifying the intent of the query, but you're also laying out how the queries would be executed.
Okay, so that means that the order of the steps matters.
Yes.
And that the graph is changing as it moves through a pipeline.
Yes. I'll come to that actually. So as you have said, Gremlin follows a data flow style execution. So the way to think of it is, as you are chaining these different steps, data flows from one step to another. So the way to think about a step is it takes a set of inputs, generate a set of output, and pass that as input to the next step. And entire execution happens in a pipeline fashion. So that means as long as one step can produce one output record, it can then pass on to the next step, and the execution can continue in a non-blocking fashion. Of course, there would be steps where you want to do certain operation in a blocking fashion.
Sure.
Right. Now that we understand like the basic anatomy of a Gremlin query, let's look at some of the different types of steps or different operations that you want to perform. So first we have map steps. Map steps, like as the name suggests, the operator maps an input object of type A and convert them output object of type B. So for example, as you're walking the graph, you're on a vertex, now you want to go to an edge, or you want to go to a property. So you're basically converting, you're taking a set of vertices as an input and converting them a set of different object.
Okay.
So here I can take a quick example. So I have a very simple toy graph of Satya and some of his direct reports.
Okay, the boss.
Yeah. So if you look at this step here, so it basically says g.v Satya. So give me the vertex of Satya. And then this step, out E, it's basically taking Satya's vertex as an input and then converting it a set of outgoing edges. So you'll get a set of edges. So here the edges are the people that reports to him, and also some of the things that he is working on, like hit. Yeah. Now, next we're gonna talk about filter steps. The way to think about filter steps is you are scoping down the amount of data a Gremlin query is touching during execution. right? So filter steps are useful when you want to make your query more efficient and make it low latency. So I'll take an example here.
So it sounds like the sooner that I can filter something out, the faster, the better the whole thing is going to expand.
Yes. So the way to think about it is you can write two different Gremlin query that outputs the exact same results.
Yeah.
But if you can apply certain filter upfront into the query, then your execution would be much faster.
So you wouldn't want to, like, for example, sort the entire database, the entire graph rather, and then filter.
Yeah.
You'd filter everything, minimize it, and then sort.
Yeah.
Okay.
So I can take some example.
So for filtering.
Yeah. Sorry.
No worries.
Yeah.
So which one's a good filter?
Yeah. So let's take this example here. So in this example, what you're trying to find out is who are the people that reports to Satya.
Right.
Right. And as you see upfront, we are specifying g.v. So this means this query is inefficient and it's taking the entire vertex set as an input.
So you say take from the graph G, take all the vertices, and then look at all the reports and walk backwards up to find the Satyas.
Yeah. And so even though if you run this query, it generates output Amy and Scott. Sure. One way to apply filter here would be to you just say, if you know for the fact that only CVPs or only EVPs report to Satya, you can specify that as a filter and you can say title.
And now I've just cut this down from many, many thousands to a dozen.
Yeah. So this query will output the exact same results, but inherently it's running much faster. And in terms of Cosmos DB, it's not only running with low latency, it is also costing you lesser RUs. So when you're writing this query, it's recommended you look up all the different filtering steps that you can apply and make your query more efficient.
That's a really good point that you just made. I want to make sure we double click on, because even though Cosmos DB is so fast, it can hide complexity from you. You just did a query, and to us it felt like they both cost equally.
Yeah.
Because Cosmos DB is so fast.
Yeah.
But the second one costs less money because less work was done.
Yeah.
That's a really great point. Okay.
Now I want to talk about side effect steps. So the way to think about side effect steps are you are walking on this graph, and as you are walking, you are collecting information as a byproduct of the walk without affecting the nature of the walk. Right?
Okay, that makes sense.
Yeah. So
observing it didn't change it.
Yes.
Now, there are operations that will change it if I observe it? They will cause side effects?
I'll talk about it a little bit later.
All right.
So let's take this query. Let me write it down.
So what's our goal here?
So so let's say I execute this query.
Okay.
So here I found out that Scott and Amy reports to Satya.
Right.
And let's say I'll add another level of indirection here. Now out of Scott and Amy, I found that Jason now reports to Scott. So the goal of this query is I want to find out in this toy graph what are the vertices or what are the reports that are two steps away from Satya.
Okay.
Right. Now in this case it's only outputting one vertex, right? But now let's say you want to find out, as you're walking the graph, you want to find out all the reports that you have found. So one way to do it is break this query into two, where you say g.v out one query and then two outs another query, get the results and join them. other way would be to use side effect. So what you can do here is there is a side effect step called store. So you can store the output of the first part of the traversal into a variable x. You can store it into the same variable, the output of the second step.
Okay.
And then you can call a step called cap to output all the results.
Does it make a union of them?
Yeah, it makes a union of them. So if you look at the JSON output, all the three vertices, Jason, Amy, and Scott would be there.
I see, but because it's a union, they are unique, and I didn't get two Scotts or two Jasons.
Yeah, yeah.
Because there aren't two in the graph.
Yes, yeah.
Very cool.
So the other way to write this query, as I have mentioned, would be to split them into two queries that will not only cause you more latency, but will cost you more. In this case, with side effect, you can just walk the graph once and collect as much information as possible.
That's cool. What do we have next in the remaining minute?
As I was talking about this side effect step, I also talked about a barrier step, which is basically as you're executing, it says, stop here, give me all the results that you have calculated so far. So this was the cap step here.
These are well named. I like these names. It is a barrier within the pipeline.
Yes. So when you said cap, it's basically telling, gather all the output and give it to me.
And people who understand Gremlin will be appreciating this experience, because this is exactly what they're doing all day long, except now they get a big cloud scale geo-replicated database to do it with.
Yeah.
So is this available? People can use Gremlin on Cosmos? No problem. It's one click when you make your Cosmos database.
Yes. Yeah.
Is there anywhere that people can learn more about this, or docs specific to Gremlin on Cosmos?
So there are docs on our website where people can learn about these steps. So we document all the steps that we support, but you can always go to Tinkerpop's website where these steps are clearly documented and there are examples.
And then also on Cosmos DB, there's a section called the Graph Introduction that talks about these things as well.
Yep.
Thanks so much for sharing with us today.
Yeah.
All right, I am learning all about working with graphs and Gremlin on Cosmos DB here on Azure Friday.